Today's lesson, we're going to be starting to look at position versus time graphs. Okay, and so for position versus time graphs, there's really only two skills that you need to properly analyze them, and that is to be able to read the values off of the graph. And this should be pretty simple and straightforward for you guys because it's just being able to read a graph. It should be things that you've practiced all out through your school years. And then also to be able to find the slope of the graph, okay? And this is something that you should have covered in geometry class, so hopefully it is kind of a review for all of you. Okay, so considering this graph that we have, this is a position versus time graph for walking to school. Okay, so going through each of these questions, where does the student start walking from? Okay, so the start would be time 0. So if we look at time 0, the position in this case is here at 0. Okay, so their position is at 0 meters. Because if we look at the units on the y-axis, okay, it's in meters per second, or meters south. Okay, and so we can also assume or guess that this student is at home, is their starting position. Okay, so where is the student walking to? We know that the location they're walking to is the school. Okay, but if we look at the graph and we look at the ending time, what position is that student in? They are 80 meters south of home, basically. Okay, how far is the student's home from the school? We kind of already answered that in the last one. They are 80 meters south. Okay, and how long does it take for the student to walk to school? So if we look, when it reaches the school, which is here, if we go down and look at the time, okay, it's at 60 seconds. So it doesn't take very long, okay? How far has the student walked after 30 seconds? So if we look at 30 seconds, okay, moving up, we find the point in which the line crosses, and then going over, we can see that it was at position 40 meters south. Okay, and then lastly, how long did it take the student to walk 20 meters? Okay, so we look at 20 meters, go over, find the point it meets at the on the line, and go down. It's at 15 seconds. Okay, so all the information above can be read from the graph. So it's going to help provide information about the position of the object, the person, depending on what kind of problem you're looking at. Okay, so the other skill that's required is finding the slope of the graph. Okay, so for slope, if you remember back to math class, slope is denoted with an M, and it's rise over run. Okay, so if we try to find the slope of this object, or of this person, I guess you would say, the total distance, okay, or the rise, so the y-axis that we reach is 80 meters south. Okay, over the run, or the x-axis, it goes to 60 seconds. Okay, so our answer, when simplified, is 1.3, and the units that are left behind are meters per second south. Okay, so one thing that you should notice examining these units, is that it's giving you a hint at what the slope actually tells us on a position versus time graph. Okay, so the units of the slope are meters per second with direction in this case. Okay, so that matches units for velocity. Okay, so based on this, we can state that the slope of a position versus time graph gives velocity. Okay. All right, so moving on to the average velocity equation. Okay, so we're still going to kind of use the slope equation that we used before to figure out the units. Okay, so m equals rise over run. Okay, and so we're going to kind of use in math class, you might remember that we use y2 minus y1 over x2 minus x1. Okay, we're going to use similar math here, but we're going to put in the units that we use here in physics. Okay, so for m, we're going to have the d, or position, 2, let me change it back to my color, d2 minus d1, so remember those are positions, and then all over t2 minus t1. Okay, and so this is telling us the velocity, the average velocity. Okay, so we're going to have change in position over change in time. Okay, and so you can use whichever variation best fits. Okay, you might also see this, or might use this. The D2, position 2, minus position 1, all over change in time. Okay, so whichever equation best suits your problem, that's the one that you should use. Okay, so moving on to an example. Through comparing graphs on the same scale, we can learn more about what the shape of the graph can tell us. 3 siblings walk to the same school 300 meters east from the same home. Rank which sibling you think is the fastest and the slowest, then calculate the slope to determine their average velocity. So just take a moment looking at these graphs. Which one do you think is the fastest? Which one do you think is the slowest? Okay, and then we're actually going to go through and calculate the average velocity for each of them to see who actually is the slowest. Okay, so starting with this sibling, we're going to use the equation average velocity equals change in position over change in time. Okay, so if we look, the displacement or position change that they meet is at 300. So position is 300 meters east. Okay, and it took this person 240 seconds to reach that 300 meters position. So 240 seconds. Okay, so when we divide it out, their average velocity comes out to be 1.25 meters per second east. Okay, moving on to sibling number 2. Using the same equation, change in position over change in time, okay? This sibling, they reached the 300 meters in 120 seconds. Okay, so plugging in our information, our change in velocity is 300 meters east over the time of 120 seconds. So when we divide it out, our average velocity comes out to be 2.5 meters per second east. Okay, and then the last sibling, we're going to use the same equation, change in position over change in time. Okay, this sibling made it the 300 meters in 180 seconds, so plugging it in. 300 meters east, all over 180 seconds. So our average velocity for the third sibling, Cameron, is 1.6 meters per second east. Okay, so looking at the 3 different siblings, we had sibling 1 traveled at a speed or at a velocity of 1.25. Beth traveled at 2.5 meters per second, and then Cameron traveled at 1.6 meters per second. So our winner of the siblings, the fastest one was Beth, and our slowest one was Alfie. Okay. So how the slope of the line on the position versus time graph relates to an object's velocity. Okay, so if we look at the slope of these, okay, and the steepness of the slope, we can kind of summarize which one was faster. So if we look at Beth, her line has a very sharp incline compared to Alfie's, who kind of has more of a slower incline. Okay, so we can state that a steeper slope indicates a faster velocity. Okay, so a position versus time graph can be made of multiple lines with different slopes. So if we look at this one, we can kind of look to see and describe the motion of this, this student who is walking. Okay, so the first part of the walk, we have this line here. So we can say for that the student goes, let's see, they went 40 meters west in, and it took them, let's see, the times are a little bit different here because it's not split up into 5, it's split up into 4. So I believe it's 2.5-ish. Yeah, 2.5 is each of these, or 2.75. I'm not exactly sure. Okay, but they're traveling at a certain speed. They travel 40 meters, and then here, if we look, we have a flat line. So from this time to this time, the person is staying at the position of 40 meters west. Okay, so they are basically stopped. Okay, they're stopped at 40 meters west. Okay, then our line continues here, and you'll see there's like a little bit here, and then we have a break where it goes here. Okay, so the pink line, this one is actually very steep. So student walks quickly to position 50 meters west. And then for our blue line, they are still walking, but at a slower pace than previous. And then they reach the 80 meters west, and then that's at 60 seconds. Okay, so there can be different parts or different aspects to the position versus time graph. Okay, so during what time interval is the student moving the fastest? And it was that pink. So the pink line, which is between times 33.75 seconds and 37.5 seconds. Okay. To determine the student's average velocity at that time interval, okay, if you remember, our average velocity is going to be position 2 minus position 1 over time 2 minus time 1. So we can plug in this information that we have. So if we look at the position, they went from 40 meters to 50 meters west. Okay, so the average velocity equals 50 meters. That was the second position, minus the 40, the starting position. And then our time was these two up here. So 37.5 was the ending time minus 33.75. And so whenever you do the math for this, you get 2.6 meters per second west. Okay, what is the meaning of the horizontal line? Provide it by determining the slope of that section. Okay, so we kind of already talked about this. They're staying at position 40 for a set of time. Okay, and so they are stopped. Okay, but to prove this, we can find the slope, which would tell us the velocity of that person. So for the average velocity, we have our d2 minus d1 all over t2 minus t1. So I'm just going to plug in the numbers. So they were at position 40, and then they were at the end, they were still at position 40. And the times was from 33.75 minus the start time, which is here, which was 22.5. And so because up here we're going to get a 0, anything divided by 0 is just going to be 0. So our average velocity is 0, which is what we were expecting because the person was stopped. Okay, and the way that I found the time intervals, just in case you are confused, there's 15-second jumps between here, and then there's 4 basically blocks between there, or ticks between there. And so you would take 15 divided by 4, and then that's how I get the interval jumps between each of the boxes. Okay, so how does this student's average velocity for the entire walk to school compare with the first student's average velocity? Okay, so for this student, the average velocity, which is change in position over change in time. So this student went 80 meters in 60 seconds. So 80 meters in 60 seconds, their average velocity is going to be 1.3 meters per second, and they are headed south. Okay, and then the other student also went 80 meters in 60 seconds. Okay, but theirs is going to be 1.3 meters per second west. Okay, so if we look at both of these, they both walk the same distance in 60 seconds. Okay, the magnitudes are the same, so they're both walking 1.3 meters per second, but they're going in different directions. So we have one that's going west and one that's going south. Okay, so we can compare graphs in order to figure out these different things. Okay, examining a position versus time graph for track practice. Okay, so we're going to describe the motion of the object or the person. Okay, so for this person, they start out at position 0, and then they run 25 meters north in 5 seconds. Okay, that's what their position is at that point. So let me just highlight this. Okay, for the next person here, they are going to remain or stop at position 25 meters north of the starting line, and they're going to be there for 5 seconds. Okay, because it was already at 5 seconds, and then we go to 10, so this interval is 5 seconds. Okay, then we have our next stretch. They're going to run from position so from 25 meters north to 50 meters north. And this takes them, so we started at time 10 and then end at time 15, so in another 5 seconds. Okay, our next part here, they're stopped again at position 50 meters north. And they are going to be stopped for 5 seconds. the next part here, they're going to run again from position 50 to 75 meters north of the starting line. Okay, and this takes them 5 seconds. Okay, then we have this stopping point up here. So they're stopped at position 75 meters north of the starting line, and this is for 2.5 seconds. Okay, and then we have this last stretch. Okay, so in this last stretch, they are running from 75 meters north to 0 meters. Okay, so they're actually running back towards the start line. Okay, and this takes them, let's see, I'm going to take them 5, 10, 12.5 seconds. Okay, so what is the runner doing in the scenarios with the horizontal lines? We've kind of already talked about this, but they are stopped. Okay, because our slope is 0, meaning that their velocity is 0. So find the average velocity of the runner in the last section. What does the sign mean? Okay, so remember that velocity, our average velocity is going to be our position 2, or our ending position, minus the starting position all over time. Okay, so we're going to have, if we plug in the numbers, our position 1 was 70, position 1 was 75 meters north, and our position 2, or any position, was 0. So we're going to have 0 minus 75, and then our time interval was at 27.5 was the starting, and then we ended at 40 seconds. So 40 seconds minus the 27.5, then we should have gotten an average velocity of -6 meters per second north. Okay, so the negative sign just indicates the direction. So it's basically opposite of north. So they actually ran, we could say, 6 meters per second south. Okay, so they're running back to the start. So if they ran north away and then they ran backwards, they would be running south. Okay. What is the runner's final position and overall displacement? So his final position, okay, the final was 0 meters. Okay, if he started at 0 meters and ended at 0 meters, his total displacement was going to be 0 meters.